7a, we have y equals negative 2x plus 7. So the way that this one's technically written, it's in that y equals mx plus b form. So it's in that slope-intercept form. So this tells you this is the y-intercept. And this is always your slope. Good job. Okay. So if I go to graph this, making a perfect little xy coordinates. This 7 is telling me where I'm crossing the y-axis. So I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. And then my slope is negative 2. So if you think of the change in y over the change in x, or that rise over run, some people like to throw it over 1. So from this point, you're going to go down 2 and to the right 1. And perfectly drawn-ish, right? Sometimes in life, you just make your dots bigger, and it makes your line look better. Okay. And then just make sure you get those arrows on the end, because it is a line, and a line goes on and on and on forever, right? All right. Any other ones? Number 6, like technically, like at number 6, like you really should like know how to do number 6. It's just trying to get you to think about like, well, how would it kind of look? So ultimately, like the big thing is, you know, in a sense, if you kind of could get kind of like those little lines kind of like going through there, like not so maybe not much the open circles and closed circles. We'll get into all of that like later, but kind of knowing like you're going to have that one bus, no matter how many kids you have on, up until you get to 90. And then you got up to like 2 buses, and you had 2 buses until you ended up getting to 130. You know what I mean? So trying to get those are called step functions. And if you could kind of get something along that, you're doing good. Anything else? Good on everything else? All right. All right. So today we got a little bit of notes to take. And then there's a little activity for you guys to kind of work on that Desmos before you kind of start on your homework. And it's just to kind of see how some different functions kind of work. Right? So this is the 1.1.2, and they're calling it using a graphing calculator. So the one nice thing, if you're doing using the CPM book online, like when they actually have Desmos activities, it's built right into it, and you just click on it and it takes you right to Desmos. If you're like working at home on your assignment and you need a graphing calculator, if you go to my homepage, my website, and under those resources, there was that tab for those Desmos calculator, right? Or if you have a TI-84, you can use that. Or there are some in the media center that you can check out, like a textbook. You're just responsible for, you know, battery replacement and not destroying it, kind of thing. So that's an option as well. Sound good? Everybody good? All right. So we're going to start by talking about linear equations. Do you guys know what a linear equation is? What's it do? What's it make? Yeah, it forms a line, right? So it forms a line when it's graphed. So number 7 that we just went through, that problem would be an example of a linear function, right? There's two forms that we're going to look at today. One of them is called the standard form. And these are just the way in which they kind of write out the problems. So they're going to write it as like ax plus by equals c. And I believe on yesterday's assignment, I think there was one on there, or was it the day before? And you had to kind of like graph it. So there's a couple different ways of graphing it. So an example of this they would write, say, like negative 6x plus 3y equals negative 18. And that's just considered standard form. So your x and your y variable are on the same side of the equal sign. That's what standard form means. And then there's slope-intercept form. Do you guys remember slope-intercept form? Y equals mx plus b, right? And on this one, m is the slope, b is that y-intercept. So an example of this one would be like y equals 2x minus 6. Right. So let's look at graphing these guys. So if I'm looking at like this top one in this standard form, so there's always pros and cons to every form when it comes to graphing it. And it's like a personal preference on what one you like the best. You can rearrange this one to get it into that slope-intercept form if you want to go through those extra steps. Or you can try and graph it from here. So there's these little things called the x-intercept. Anybody know what the x-intercept is?
You cross the x-axis.
Yep, so it's where you cross the x-axis. So which one's my x-axis? This one, right? So when I cross anywhere in the x-axis, what's my y value going to be? What's my y value right there?
0.
Yep. If I was here, say I went over 1, what's my y value going to be? If you were to give me that coordinate or that point right there, it would be 0, 1, 0, right? If I moved over 5 places, what would my, still going to be 0. So when I cross over that x-axis, no matter where I cross over that x-axis, my y value is always, it's always 0, right? So when we're looking for that x-intercept, the y value is always 0. Right? So if I look at my little equation, negative 6x plus 3y equals negative 18, if I'm looking for that x-intercept, what's my y value going to be?
0.
It's going to be 0. So guess what I can do on my equation? What can I put in for y?
0.
I can put in 0, right? So negative 6x plus 3 times 0 equals negative 18. And we love doing some algebra, right? So we get what? Negative 6x equals negative 18. What's my x going to equal? 3, right? So where am I going to cross the x-axis? When x equals 3. So there's one point of your graph. Can you move it up? Woo.
I think Landon needs more time.
No, you're good.
No, I'm good. I'll give you guys a little.
You're good.
You sure? Don't make me rush you. Right?
You're good.
All right.
I'll get it from someone else.
Yeah.
Yesterday you were going so fast, I was freaking out. I had to like watch the
Just
video and do it
just
while you were doing that Zoom.
Same thing.
Yeah, I can't really.
You just write it down.
Yeah. All right. I'll try. It's like, I don't know. It's like, I think it's just, we're in such fast motion right now, be trying to get everything up and running that, and it is, it's like, I even notice it. I'm like this all day long and I'm like, oh, it's right. All right. So then there's also this thing called the y-intercept?
Goodness.
Yeah.
So that means they're just started right now.
Yeah.
Cross the y-intercept, your x-intercept is -0.
Look at that. You already know the answer to this. Exactly. So what's the y-intercept? What happens at the y-intercept? What's definition? When it,
X is 0.
yeah, so when the graph or the line, I guess I could use line, right? So when the line crosses the y-axis. Right? So where's my y-axis? This one.
Hey, what did you just spell out the word Y? I was just listening.
All right. So what's my x value right here at the origin? 0. If I moved up 2 spots, what would my x value be? Still 0, right? If I move down here, what's my x value? 0. So if I'm looking to where I cross the y-axis, what do I know about my x value? X is 0. So now I can look at that equation again. Negative 6x plus 3y equals negative 18. And if I want to find where it crosses the y, what am I going to do?
Substitute X for 0.
Yeah, make x 0 now. Plus 3y equals negative 18. So 3y equals negative 18. Oops. Y is going to equal
No.
negative 6.
Negative 6, that's what
Yep.
I
So could I put that someplace on my graph? Where's it going to go? Down 6. 1, 2, 3, 4, 5, 6. So that's my other point. How many points do you have to have in order to make a line?
2.
2. Do we get 2 points?
Yeah.
Yep. So guess what I can do? Whoop. I can make a perfectly straight. Sometimes you make dots bigger, sometimes you make lines thicker. Right?
So what does that line represent?
So that line is that equation, right?
Okay, but you just pick 0. I don't
Yeah. Yep. Because I know that my line's going to cross the x and y axes. Right? Unless it's like, yeah. Yep. All right. If you looked at this one, right, if it was in slope-intercept form, how would you graph slope-intercept form?
You got your y-axis right there.
You go down 6 and then you go up 2 over 1 and you have it from there. You've done this before, yep. So usually a lot of times what I do when I do these, like, because I know if I'm gonna, there we go. When I look at that standard form, this one, like, because I know that I'm gonna cross my x and y axes, I like literally just cross this part off. Oh, watch. Because if I put in 0, that would go away. So y is gonna equal negative 6, all right? And then I'm going to cross this part off. And what's my x going to equal? Positive 3, right? Which is what we did. We just took our time doing it because it was the first time going through it. Does that work? Maybe. Think you guys could do some graphs if you had to. All right. So on your guys' homework, it talks about this property called the zero product property. Do you know what 0 means? Yes, sir? Yep.
That is not the answer. Shut up.
What's another word for product? Sum would be addition. Product would be multiplication, right? You're fine, right? So what the zero product property says, that if you're multiplying things and your product is 0, one or the other thing has to be 0. So in other words, if you had like A times B equals 0, because the only thing you can multiply to get 0 is 0, right? So this says that either A equals 0 or B has to equal 0.
Wouldn't one technically have this too? Like something like this?
Either they both can or one of them. That's why it's or.
Oh.
One or the other, or yeah, or both. Yep. So in math, we call these things like factors, right? Factors are things that you multiply by. So if we had like x plus 2 and x minus 1 equals 0, this whole, I cannot draw brackets. Oh, right? Oh, I know. I'm awful at them. These are called factors. No different than like when you guys were like multiplying, you know, if you were to have 12, and remember when they said, what are the factors of 12? You guys remember the factors of 12? 1 and 12, 2 and 6, 3 and 4. Right, then yes, right. So when it comes to factors, factors are the things that you multiplied by in order to get there, right? So the zero product property says that when you're multiplying these factors and it equals 0, one or the other 0. And like right there, like what are you guys doing to these two things in parentheses? Like what's technically right in between there? Is there a little multiplication symbol there that you just don't see? Right? So you're multiplying those two factors together. So if I'm multiplying these two factors together and it equals 0, that zero product property says that either x plus 2 has to equal 0 or what?
X minus 1
Equals 0. Yep. And then back to that cute little algebra. Can you solve this for x? Can you solve this one for x? What are you going to do? Get x all alone, all by himself. Yeah, get rid of this guy. How you going to get rid of this positive 2? Yeah, subtract 2 from both sides, right? And we're going to get x equals negative 2. Or, what are we going to get on this side over here? Yeah, x equals 1.